There is a forgotten story in the archives of the Second World War, a narrative that is rarely told in conventional history books. It is the story of how a British engine, considered revolutionary in its homeland, crossed the Atlantic and was transformed by the hands of American engineers into something even more extraordinary. It is the story of how necessity, ingenuity, and international collaboration created the heart of one of the most important aircraft of the war. This is the secret behind the P-51 Mustang, the fighter that changed the course of European skies. In the early years of the 1930s, while the world was still recovering from the Great Depression, a group of British engineers quietly worked on a project that would revolutionize military aviation. Rolls-Royce, a company known worldwide for its luxury automobiles, decided to apply its precision engineering expertise to the development of aeronautical engines. The result of this effort would be the Rolls-Royce Merlin, an engine that combined power, reliability, and efficiency in a way never seen before. The Merlin was not just another airplane engine. It was a masterpiece of mechanical engineering, with 12 cylinders arranged in V format, liquid cooling, and a supercharger that allowed the engine to maintain its power even at high altitudes. When the first prototypes began to be tested in the mid-30s, it became clear that Rolls-Royce had created something special. The engine produced more than 1,000 horsepower, an impressive figure for the time, and promised to give British aircraft a significant advantage in any future conflict. But Merlin's true genius lay in his details. Rolls-Royce engineers had developed a fuel injection system that allowed the engine to run in any position, even reversed during intense acrobatic maneuvers. They had created components with tolerances so precise that each part fit perfectly, reducing vibrations and increasing durability. Every aspect of the engine had been thought out, redesigned, and refined to mechanical perfection. Before you continue watching, leave your comments saying what time you are watching this documentary. And if you appreciate true stories about engineering and aviation, subscribe to the channel so as not to miss the next episodes. By the time the war began in September 1939, Merlin was already equipping the Hurricane fighters and new Spitfires of the British Royal Air Force. During the Battle of Britain, these engines proved their worth in English skies, staying aloft hour after hour as pilots defended their nation against air attacks. Merlin's distinctive sound became synonymous with resilience and hope for the British people who looked to the sky during those difficult days. But there was a growing problem. The demand for Merlin engines was insatiable. Rolls-Royce, even working at full capacity, could not produce enough engines to meet the needs of the RAF and Allied forces. British factories were overwhelmed, and the operational challenges of the time made production even more complex. Something had to be done, or the British technological advantage would be squandered for lack of productive capacity. It was at this critical moment that the British looked across the Atlantic. The United States had not yet officially entered the war, but was already providing material aid to the Allies through the Lend-Lease program. American industry was vast, modern, and, most importantly, geographically distant from European war operations. If the Americans could produce Merlin, the supply crisis could be resolved. But there was one significant hurdle. The Merlin had been designed using the British metric system, while all American industry operated with the American imperial system of measures. In 1940, Rolls-Royce representatives traveled to the United States carrying technical drawings, detailed specifications, and even a full Merlin engine as a reference. They visited several American companies, looking for one that could take on the monumental task of Americanizing the British project. Many companies hesitated. Conversion would not be simple. Every dimension, every tolerance, every specification would need to be translated from British fractional inches into the American system, without losing the precision that made Merlin so special. Packard Motor Car Company, a Detroit-based luxury car manufacturer, decided to take up the challenge. At first glance, it may seem like a strange choice. Packard was known for its sleek cars, not high-performance aviation engines. But the company had something few other manufacturers possessed: an unwavering reputation for precision engineering and strict quality control. If anyone could transition from Merlin to American production without compromising on quality, it was Packard. What followed was one of the most impressive reverse engineering feats in industrial history. A team of Packard engineers, led by men who had spent decades perfecting automotive engines, began dismantling the Merlin piece by piece. They measured each component with precision instruments, noted each tolerance, studied each machine's surface. The engine was literally disassembled down to the last screw, and each element was meticulously documented. But measuring and documenting it was only the first step. The real challenge lay in redesigning the entire engine for American manufacturing. Every British technical drawing needed to be converted. Where the British specified something in millimeters, the Americans needed to translate it to milliseconds of an inch. Where a British specification required a specific tool, Packard engineers needed to figure out how to achieve the same result with American tools and processes. The conversion went far beyond simple mathematics. Packard engineers found that some aspects of British design were difficult or impossible to replicate using standard American manufacturing methods. Instead of simply copying, they needed to innovate. They developed new casting processes to create engine blocks with the same metallurgical properties as the original British ones. They created new machining methods to achieve the extraordinarily tight tolerances that Merlin required. They redesigned entire tools and machines to produce components that met British standards. One of the biggest challenges was the supercharger, the heart of the engine air induction system. This complex device had to compress air before it entered the cylinders, allowing the engine to maintain power at high altitudes where air is rarefied. The British supercharger had tolerances measured in milliseconds. Any deviation, however small, would result in loss of efficiency or complete failure. Packard engineers spent months developing processes that could replicate this accuracy consistently on a mass production line. While working on conversion, American engineers also began to identify opportunities for improvement. They deeply respected British design, but also recognized that some changes could make the engine better suited to American mass production. Minor modifications were proposed. Adjustments to components that would be easier to manufacture without compromising performance, replacements of materials with American equivalents that were more easily available, refinements in assembly processes that would speed up production. Each proposed change was carefully evaluated. Packard engineers maintained constant communication with their Rolls-Royce colleagues, submitting modifications for approval and testing. It was an unprecedented transatlantic collaboration, with technical drawings traveling back and forth across the ocean carrying ideas, suggestions, and approvals. Despite distance and cultural differences, British and American engineers worked together with a common goal: to create an engine that could help win the war. In September 1941, almost a year after the start of the project, the first Packard Merlin engine rolled off the production line. It was externally identical to the original British, but inside contained hundreds of small Americanizations, each of them the result of countless hours of careful engineering. The engine was immediately placed on a test bench and subjected to a rigorous battery of evaluations. Packard engineers held their breath as the engine was carried to its fullest capacity, testing every system, every component, every aspect of its performance. The results exceeded expectations. The Packard Merlin not only matched the performance of the British original, but in some ways outperformed it slightly. The small improvements that American engineers had implemented resulted in a slightly more reliable and easier to maintain engine. The news was met with celebration in both Detroit and Derby, where Rolls-Royce had its headquarters. Americanization had been a complete success. But producing an engine on a test bench is one thing. Producing thousands of them, month after month, with consistent quality, was a completely different challenge. Packard began to expand its production facilities, transforming factories that previously produced luxury automobiles into precision aeronautical engine assembly lines. Workers who once installed chrome fenders in Packard sedans now learned how to assemble superchargers and complex ignition systems. The quality standards for aeronautical engines were much stricter than for automobiles. A minor defect in a car could result in a vehicle standing still on the road. The same defect in an airplane engine could cost lives. Each component needed to be thoroughly inspected. Each assembled engine needed to undergo extensive testing before being approved for installation on an aircraft. Packard implemented quality controls so strict that they sometimes rejected components that would have been perfectly acceptable in the automotive industry. Many of them were women, as young men were being recruited into the military. These workers, who the propaganda of the time would call Rosie the Riveter, became experts in tasks of extraordinary precision. They operated complex machines, inspected components with micrometers and calibrators, assembled delicate subsets that required firm hands and meticulous attention to detail. The contribution of these women to the war effort would be critical to the success of the Packard Merlin production. Meanwhile, on the other side of the country, another story was developing. North American Aviation, a relatively young aircraft manufacturer based in California, had received an order from the British to produce fighters. Originally, the British wanted North American to produce the P-40 Warhawk under license, but the company's engineers proposed something different, to design a completely new fighter that would incorporate lessons learned from the fighting over Europe. The result was the NA-73, which would later be known as the P-51 Mustang. The design was revolutionary. North American engineers, led by a talented German named Edgar Schmud, created an aerodynamic fuselage that minimized drag. They developed a laminar wing profile that allowed for higher speeds with less air resistance. The plane was beautiful, sleek, and looked promising, but there was one fundamental problem: the engine. The first P-51s were equipped with Allison V1710 engines, which were suitable for low-altitude operations, but lost power significantly at high altitudes where many of the air combat over Europe took place. The pilots who tested the first Mustangs were impressed by the maneuverability and speed of the plane at low altitudes, but knew it would be vulnerable in high-altitude combat against German fighters that could effectively operate at more than 20,000 feet. It was a British RAF officer, serving as a liaison in the United States, who had the idea that it would change everything. He observed the elegant Mustang and thought of the powerful Merlin being produced by Packard. What if these two elements could be combined? What if the P-51 could receive the heart it truly deserved? The suggestion was taken seriously, and preliminary tests were allowed. The first tests were revealing a P-51 was modified to receive a Merlin Packard, and the results were spectacular. The added power and ability to maintain that power at high altitudes turned the Mustang from a good low-altitude fighter into a world-class air superiority fighter. Maximum speed increased significantly, the rate of climb improved dramatically, and the service ceiling rose to over 40,000 feet. But perhaps the most important aspect was the reach. The P-51 Mustang, equipped with the Packard Merlin, combined with additional fuel tanks, could fly farther than any Allied fighter of the time. This meant that, for the first time, American bombers attacking targets deep inside Germany could have fighter escorts throughout the mission. Before that, bombers flew unescorted during critical parts of their missions, making them vulnerable to German fighter attacks. The losses were terrible. The combination of the American Mustang design and the Americanized engine created an unexpected synergy. The Merlin engine was slightly heavier than the original Allison, but it was also more powerful and efficient. North American engineers had to make modifications to the fuselage design to accommodate the new engine, including redesigning the hood and cooling system. The radiator was repositioned to improve airflow, a change that not only solved cooling problems, but also created a small additional boost through what is known as the Meredith effect. Each modification was meticulously tested. Prototypes flew mission after mission, being pushed to the limits of their capability. Test pilots performed extreme maneuvers, high-speed dives, sharp climbs, tight turns in simulated tests. Engineers analyzed every aspect of performance, looking for problems, identifying areas for improvement, refining the design constantly. What emerged from this process was an airplane that not only met expectations, but surpassed them in almost every measurable aspect. When the first P-51B Mustangs equipped with Packard Merlin arrived at operational squadrons in England in late 1943, the pilots were immediately impressed. Here was a fighter that combined speed, range, maneuverability, and operational capability in a way no other Allied aircraft could. The Mustang had exceptional performance at high altitude and could operate effectively in a variety of conditions. But the real revolution came when the Mustangs began escorting B-17 and B-24 bomber formations on long-range missions over Europe. The Mustangs were there when the bombers crossed the English Channel, were there over the European mainland defending the formations, and were still there on the return journey, protecting damaged aircraft during the return home. The impact was dramatic and measurable. Missions that previously presented major challenges have become more feasible. The Allied strategic bombing campaign gained greater effectiveness. The constant presence of escorts allowed air operations to continue with greater consistency. Mustang pilots quickly developed tactics that harnessed the unique capabilities of their planes. They could maneuver effectively to protect the bombers, knowing they had adequate speed and power. They could respond quickly to different flight situations. And when the fuel started running out, they had enough range to get home safely. The Mustang has earned a formidable reputation among aviators. Packard Merlin's production continued to increase throughout the war. Packard plants in Detroit operated on continuous shifts, 24 hours a day, 7 days a week. Thousands of workers dedicated their lives to producing these engines, knowing that their work was directly contributing to the war effort. Each engine leaving the production line went through a full bench test, running for hours at various power settings to ensure it was ready for operation. At the height of production, Packard was producing more Merlin engines than Rolls-Royce itself. American engines equipped not only Mustangs but also other Allied aircraft, including British Lancaster bombers and Mosquito fighters. The Americanization that had begun as an emergency measure to overcome British production limitations became a key pillar of Allied air strategy. Packard engineers never stopped improving. They continued refining manufacturing processes, finding ways to produce components with greater accuracy and lower cost. They developed improved versions of the engine that produced more power, had higher reliability, and required less maintenance. Each enhancement was shared with Rolls-Royce, and many of the American improvements were eventually incorporated into engines produced in Britain. Despite differences in approach, incompatible measurement systems, the thousands of miles that separated them, they worked together with mutual respect and professional admiration. The British recognized the genius of American production engineering, the ability to transform a handmade design into something that could be mass-produced without losing quality. Americans admired the sophistication of British design, the meticulous attention to detail that made the Merlin a masterpiece of mechanical engineering. Stories of pilots who owed their lives to Packard Merlin are endless. There are reports of Mustangs returning home with a severely damaged engine, continuing to operate when less robust engines would have failed completely. There are stories of pilots who managed to complete long and exhausting missions thanks to the fuel efficiency of the engine, coming home with the tanks almost empty but safely. There are narratives of challenging situations where the extra power provided by Merlin made all the difference. An American pilot, in his memoirs written decades after the war, described the Packard Merlin sound as the most beautiful song he had ever heard. He remembered sitting in the cabin, waiting to take off on a cold English morning, listening to the engine warm up, feeling the vibrations through the structure of the plane. He knew that engine, built by workers he would never know, designed by engineers whose names he would never know, would take him through challenging skies and bring him back home. It was a machine, but it was also a companion, something he trusted his life with completely. As the war progressed, Allied air superiority became more evident. In large part, this was due to the P-51 Mustang and its Packard Merlin. The skies over Europe gradually became safer for Allied operations. The Mustangs not only protected bombers, but also carried out various operational missions. In the Pacific theater, although the Mustang arrived later and outnumbered, it also made significant contributions. Equipped with even larger fuel tanks, the Mustangs could escort B-29 bombers on extremely long missions. The extraordinary range of the P-51 allowed it to operate from distant bases, reaching targets that were previously beyond fighter escort capability. By the time the war ended in 1945, Packard had produced more than 55,000 Merlin engines. It was an impressive number that represented millions of working hours, billions of machining operations, countless quality inspections, and an unwavering commitment to excellence. Each of these engines had been built with the same care and attention to detail as the first engine out of the experimental production line in 1941. The impact of Packard Merlin extended far beyond the war. The experience gained by Packard engineers and workers in the production of these high-precision engines has influenced American industry for decades. Techniques developed to manufacture Merlin components have been applied in other areas, from jet engines to industrial equipment. The culture of quality and precision that Packard developed during the war became a standard that other companies aspired to achieve. For aviation, the legacy has gone even deeper. The P-51 Mustang, powered by the Packard Merlin, set new standards for what a fighter could be. It demonstrated that range and performance were not mutually exclusive, that an airplane could be simultaneously agile and a long-range platform. These principles would influence the design of jet fighters in the following decades. The story of Packard Merlin is also a lesson in the importance of international collaboration. In a time of global crisis, two nations with different engineering traditions, different measurement systems, different approaches to manufacturing, have managed to work together to create something extraordinary. They overcame technical, linguistic, and cultural barriers because they shared a common goal and a deep mutual respect. It is easy, looking back through the decades, to forget how unlikely success was. The Americanization of Merlin required the conversion of thousands of specifications, the redesign of countless tools, the development of new manufacturing processes, all while the world was at war and time was as precious a resource as any strategic material. The fact that it was successfully accomplished, and accomplished so well that American engines often outperformed British originals in reliability, is a testament to the dedication and skill of the people involved. Many of the engineers who worked on the project were ordinary men and women who were called upon to accomplish something extraordinary. They worked long hours, solved seemingly impossible problems, persisted in the face of setbacks and failures. They did this not out of glory or recognition, but because they knew that their work mattered, that every engine they produced could save lives and bring the end of the war closer. The workers on the production lines were also silent heroes of this story. Many of them had left other careers to work in the war factories. They learned completely new skills, mastered precision techniques that required years of practice to perfect, worked in challenging conditions with the constant pressure of meeting ever-increasing production quotas. Their work was repetitive and exhausting, but every tight screw, every component inspected, every engine tested was a small victory in the larger war. After the war ended, many of these engines continued in service. Some Mustangs have been transferred to Allied air forces around the world, serving in minor conflicts and patrol missions for years. The Merlin engine proved to be as durable as it was powerful, with many engines accumulating thousands of hours of operation before finally being retired. Some still fly today, in preserved warplanes appearing in air shows, allowing new generations to hear the distinctive roar of the Packard Merlin. The sound is unmistakable. It is more serious than many modern engines, with a rhythmic pulsation that reflects the 12 cylinders firing in sequence. There is a musical quality to it, as aviation enthusiasts often note, a combination of raw power and mechanical refinement that perfectly captures the essence of what the engine represents. When a Mustang flies low over the audience at an airshow, with the Merlin running at full power, the sound crosses you, resonating not only in your ears but in your chest, reminding you of a time when human engineering was applied with desperate urgency to defend freedom. The history of the Packard Merlin and the P-51 Mustang is also a reminder of how technology shapes historical events. Without the proper engine, the sleek design of the Mustang would have remained just an unfulfilled promise. Without the ability to Americanize the Merlin, the Allies would have faced a critical shortage of high-performance engines. Without the long-range escort that the P-51 provided, the strategic bombing campaign would have continued to suffer unsustainable losses. Each of these factors influenced the course of the war in measurable and meaningful ways. But perhaps the most important lesson is about perseverance and innovation in the face of seemingly insurmountable challenges. When Packard engineers began working on the Americanization project, many experts were skeptical. The task seemed too big, the schedule too short, the technical differences too insurmountable. However, through hard work, creativity, and refusal to accept defeat, they succeeded. They not only copied the British design but improved it, adapted it, made it their own while maintaining everything that made it exceptional. Today, when we look at the challenges of modern engineering, from climate change to space exploration, there are lessons to be learned from this story. The willingness to learn from others, to adapt ideas from different cultures and traditions, to work together toward common goals, remains as important now as it was during the Second World War. The combination of different perspectives and expertise can create results that surpass what any nation or company could achieve alone. The story also reminds us of the importance of investing in technical capabilities and engineering education. The engineers who Americanized Merlin were products of an educational system that valued rigorous technical skills, analytical thinking, and practical problem-solving. They had spent years learning their craft, mastering fundamental principles of thermodynamics, fluid mechanics, materials science, and manufacturing processes. This in-depth knowledge allowed them to approach Americanization design not as a mechanical copying exercise, but as a complex engineering problem that required genuine understanding and creativity. As the world faces new challenges in the 21st century, the need for such expertise only grows. The problems we face, be they related to sustainable energy, transportation, communications, or health, require sophisticated engineering solutions. The Packard Merlin story suggests that these solutions will come not just from brilliant individuals working in isolation, but from collaborative teams that combine different forms of knowledge and experience. Mustang also teaches us about the importance of systems. The plane was remarkable not because it had a single exceptional component, but because all of its systems worked in harmony. The Merlin engine provided power, but that power needed to be translated into motion through a carefully designed propeller. The aerodynamic fuselage minimized drag, but needed to be structurally strong enough to withstand the forces of air operations. Flight controls needed to be responsive but not so sensitive as to make the plane unstable. Each element of the design was optimized, and then the entire system was optimized as an integrated suite. This systems approach is increasingly relevant in a world of complex and interconnected technology. Rarely is it enough to optimize a single component. Instead, we should think about how all the elements of a system work together, how changes in one area affect other areas, how to achieve not only local excellence but global excellence. The engineers who worked on the P-51 understood this intuitively, constantly balancing compromises between weight, power, range, speed, and maneuverability. There is also a human dimension to this story that should not be forgotten. Behind every engine produced were real people with real lives, hopes, and fears. Many of the women who worked on Packard's production lines had husbands, brothers, or children serving abroad. They knew the engines they built could be on the planes that protected their loved ones. This personal connection gave his work a meaning that went far beyond a simple job. It was a way to contribute directly to the war, to do something tangible to help bring your soldiers back home. Similarly, the pilots flying the Mustangs developed a deep respect for the men and women who had built their planes. They knew that their survival depended not only on their own abilities, but on the quality of the equipment they operated. Every time an engine kept running in adverse situations, every time a plane brought them home through challenging conditions, it was a validation of the work of those workers in Detroit they would never know. This chain of interdependence, extending from factories in Michigan to air operations over Europe, is a powerful reminder of how our actions affect others, often in ways we never see or fully understand. The worker who inspected a critical engine component never knew which specific aircraft would receive that engine, or which pilot would fly it, or what mission it would support. However, his careful work potentially saved lives thousands of miles away. In the end, the story of the British Merlin engine Americanized by Packard and its union with the P-51 Mustang is much more than a technical narrative about aeronautical engineering. It is a story about international cooperation, about overcoming differences to achieve common goals. It is a story about innovation under pressure, about finding creative solutions to seemingly impossible problems. It is a story about the value of hard work and dedication, about how ordinary individuals can accomplish extraordinary things when called upon to do so. It's also a story about legacy. The P-51 Mustang remains, decades after the end of the war, an icon of military aviation. Its sleek silhouette is instantly recognizable to enthusiasts around the world. The sound of its Packard Merlin engine continues to thrill audiences at airshows. And the lessons learned in its development, both in terms of aeronautical design and manufacturing processes, continue to influence modern aviation. When you see a Mustang flying, or hear the characteristic roar of Merlin, you are witnessing the result of thousands of engineering decisions, millions of hours of work, and the collaboration of two great industrial nations united by a common purpose. It is a tangible reminder that when we face existential challenges, humanity is capable of remarkable things. We can innovate, adapt, collaborate, and overcome obstacles that seem insurmountable. The secret of the P-51 Mustang was not just its powerful engine or its sleek fuselage. It was the synthesis of British and American engineering, of innovative design and precision manufacturing, of strategic vision and meticulous execution. It was the product of countless people working together toward a shared goal, each contributing their unique skills and efforts. And it was ultimately a demonstration that when we face big challenges with determination, creativity, and courage, we can prevail. Today, the few Mustangs that still fly serve as flying ambassadors of a bygone era, reminding us of the achievements of a previous generation and inspiring us to face our own challenges with the same determination and ingenuity. Each time one of these planes takes off, carrying the beating heart of a Packard Merlin, it is a celebration of the human spirit, of the ability to overcome, create, and win against all odds. This story belongs not only to aviation historians or war enthusiasts, but to all of us. It is a reminder of our collective potential, that when we work together, when we combine our strengths and minimize our weaknesses, when we refuse to accept failure and persist in the face of adversity, we can achieve the extraordinary. The British Merlin engine Americanized by Packard was not just an engineering triumph. It was a triumph of the human spirit, a demonstration that in challenging times we can still find light through cooperation, innovation, and unwavering determination. May we always remember these lessons. May we honor those who came before us, who built these remarkable machines and served with dedication. And may we, in our own time and in our own ways, demonstrate the same dedication to excellence, the same commitment to collaboration, and the same refusal to back down from difficult challenges. For this is how we advance as a civilization, and this is how we truly honor the legacies of those who preceded us. May Lord God always bless those who have dedicated their lives to this cause, and may we always be inspired by their achievements to build a better future.